Hey third graders, Miss Whitford again. I'm just going to take a quick moment here to show you another way that you can do an illustration for equivalent fractions. Okay, so when we think about equivalent fractions, it's going to be the same amount that's kind of like talked about or shaded in, but sometimes you're going to break that whole into different pieces. So let me show you what I mean. So if I make a box like this, okay, and I'll tell you, full disclosure, it is not going to be exactly to scale because I'm not great at doing it exactly to scale, but I will do my best, okay? So if I were to break this in half, okay, that means I now have two equal pieces, right? I have two equal pieces. So that means that this side is 1/2 and this side is 1/2. I am going to shade in, one of the equal pieces, okay? So if I'm looking at this to see what's shaded in, I know that 1/2 is shaded in, okay? Now, as I go forward, I am not going to change the amount of highlighter that's shaded in at all. However, I am going to add some lines to show you how you can show this same amount, but with an equivalent fraction, okay? So this amount of highlighter that's shaded in is 1/2. But if I draw a line across, how many equal pieces have I made my whole into? That's right, I've made it into 4 equal pieces. 1, 2, 3, 4. So my denominator is going to be 4. Remember, I didn't change the amount that's shaded in here. So now if I'm looking at the boxes, how many boxes are shaded in? 1, 2 boxes are shaded in. So 1/2 and 2/4 are equivalent. Oh wait, there's more, you guessed it. What if I wanted to make this into 8ths, okay? So to make it into 8ths, I'm going to take each box and I'm going to break each box in half. All right, now I have 8 equal pieces. That's my total amount, that's my denominator. 1, 2, 3, 4, 5, 6, 7, 8 to get there. So 8 is going to be my denominator. How many pieces are shaded in? 1, 2, 3, 4. So that means that 1/2, 2/4, and 4/8, those are all going to be equivalent fractions. You can also do this with thirds, sixths, and even 12ths if you really, really want to. Okay, so same thing, I'm going to draw a rectangle. Again, not to scale. And I'm going to break it into thirds. You could do the thirds across this way. So you could do it where it's like this. If you don't like it like that and you want to do it a different way, you could also do the thirds like this. 3 equal pieces. Okay. I like it like this a little bit better, but it's just your preference. Okay. So I'm going to actually shade in a different amount this time. I'm going to shade in 2 of the thirds. I'm going to shade in 2 of the thirds. Okay, so if I'm writing the fraction that's shaded in, my whole is 3. The total number of pieces is 3. The amount shaded in is 2. So denominator is 3 because that's the total number of pieces there are, and amount shaded in is 2, what I'm talking about. Okay, now I'm going to break this into 6ths. If I take my box. What? Crazy, right? So now I have 6 pieces. Okay, so 2/3, I have 1, 2, 3, 4, 5, 6 total pieces. How many pieces are shaded in? 1, 2, 3, 4 pieces totally shaded in. If I wanted to make this into 12ths, I could. Third graders aren't responsible for 12ths, but just in case you're like, oh, this is fun, I want to keep going, you could do it. So, meaning I'm going to be breaking this, my 6 pieces. Each piece is going to get broken in half. So I'm going to do a line here, a line here. Oopsies, let me go up here so I can draw that line. There we go. In half and in half. Okay, so now looking here, how many total pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total pieces. Total pieces is the denominator. That's going to go on the bottom. And how many pieces are shaded in? 1, 2, 3, 4, 5, 6, 7, 8 pieces shaded in. So this is another way that you can, if you don't want to use your graph paper, you just want to think, oh, can I use this to make an equivalent fraction? You can do it that way too.